So this is our review for our major quiz 2 that's coming up for intermediate algebra. So the first problem we're going to look at is the square root of 121 x to the fourth. So this is a perfect square of 121. That is 11 times 11. And if you don't know that, you can put it in your calculator. And then x to the fourth, if we take the 4 and we look at dividing it by 2, because it's a square root, then we get 2. So this is just going to be 11x squared. If we look at the cubed root of 729 x to the ninth, we would put this in the calculator first to see if it's a perfect cube, and it is. It is 9. 9 times 9 times 9 will get you 729. And then the x to the ninth, divide by 3, will get us x cubed, and we got to put that 9 in front. So those are just perfect squares and perfect cubes. Now if we look at the next term, we have the square root of 60xy squared. So this is not a perfect square, so we're going to have to factor that down. And you can use any of the factors you want. You could do 2 times 30. We're going to do 4 times 15 just to show you can use anything. It doesn't matter. 4 would be 2 times 2, and 15 would be 3 times 5. So square root of 2 times 2 times 3 times 5, I have 1x, and I have a y times a y. And you could have done these up here the same way, but because they were perfect squares, I'm letting you know that you can just find that answer. All right, because it's a square root, we're looking for groups of 2 of a kind. So that gets me a 2 on the outside, a y on the outside, and I'm left with 3 times 5 is 15 and an x. So this would be your final answer. On these, you're okay just because they're perfect ones, but on this one, you're going to have to show work. Our next one would be the cubed root of 216 x to the fifth, y to the seventh. Well, 216 is actually a perfect cube. It is going to be a 6. So you could put that in the calculator, and if not, then you could break it down the same way, and you'll end up pulling a 2 and a 3 out. But always try to see if they're perfect ones, because it'll make it a little bit clearer to you, and it's a lot less work if they're perfect ones. So the cube root of 216 is going to be a 6. And then I still have, I'm going to work this in a stage here, 6x to the fifth, y to the seventh. So I've got to figure out that part there, because these don't just divide by the 3. You can write these out as 1, 2, 3, 4, 5 x's, and 3, 4, 5, 6, 7 y's. So I'm looking for groups of 3. So here's a group of 3 that would come out. Here's a group of 3 that will come out. Here's a group of 3 that will come out. So that'll get me a 6 and an x, and I get 2 y's, so that'll be y squared. And then left inside would be x squared and a y. So if the number is perfect, then you can do this with your letters to figure out. You can also use subtraction. So 5 minus 3 would leave us with 2. 7 minus 3 would get us 1 out. That would leave us with 4. We could pull out a second one. So that's where we're going to get 2, and we'd have 1 left over. So either way you want to do with that is okay. All right, so the next one, we have the square root of negative 49. Recall that we can't take the square root of a negative number, but remember that I is equal to the square root of negative 1. So we can take out that negative by pulling out the I, square root of 49, and so it'll be equal to 7i. You would need to show this step because you have to take out the I first before you can take the square root. All right, our next set of problems, we have the square root of 5 times the square root of 3 Well, because they're both square roots, we can put them underneath the radical and get the square root of 15. The cubed root of 10y squared times the cubed root of 3x. We can do these because they're both cubed. Up here we could do them because they were both squared. If we had a square and a cube, you can't do this. You can't just multiply them together. We'll put this underneath the radical. We have 10 times 3 would get us 30. And then we have an x and a y squared. Now, this one, it stays put the way it is because we know the factors were just a 5 and a 3. We have a 3. A 10 would only break down to 5 times 2. There are no groups of 3 of a kind, which is what we had before. So this, again, would be your final answer because there's nothing else that can reduce. If it will reduce down, you must do that. All right. If we have the square root of 3z times the square root of 2z, we'll end up with 3 times 2 will get us 6z squared. Now that z squared we can take the square root of, so we'll end up with z square root of 6. So do make sure whether or not you can reduce those down, because if they will reduce, you have to do that. Otherwise, you haven't simplified it as much as possible. And so make sure you're aware and you pause and look at your answer. The previous ones wouldn't, but this would be our final answer on here. All right, part D, we have the cubed root of 5x times the cubed root of 25x will get us the cubed root. 5 times 25 would be 125, and x times x would get us x squared. Well, 125 is a perfect cube. It is 5 times 5 times 5. So the 5 would come out, and we'd have the cubed root of x squared. So that would be your final answer for this problem. Now here we have the square root of -3 times the square root of -9. On these, you have to take the i's out. We're not just going to multiply. We've got to take out the I. So I square root of 3 times I square root of 9. Well, I can take the square root of 9. So this would get me I square root of 3 times 3i. I times 3i would get us 3i squared times that square root of 3. I squared is going to be equal to -1, because remember we talked about I is equal to the square root of -1, and if you multiply that by itself or you square it, you will get -1. So this is 3 times -1 times that square root of 3. So this will become -3 square roots of 3. And that would be your final answer on that one. All right. Our next problem is the square root of 6 over 49. So this is where we can recall that we can break this up to the square root of 6 over the square root of 49. 49 is a perfect square, so square root of 6 over 7. And that would be your final answer. If we have the cubed root of 64 over 343, we can again break it up. Cubed root of 64 over the cubed root of 343. Well, the cubed root of 64, that is a perfect cube, and it is 4. 4 times 4 times 4. And 343 is also a perfect cube. It is 7 times 7 times 7. So that would be your final answer for that one. And on this particular problem, because they were both perfect cubes, you could have just taken it from there. But if they're not, you do have to split them up. All right, let's look at our third problem with this. We have the square root of 27 divided by the square root of 3. Now, 27 and 3 are both not perfect squares. So what we're going to do is put them back together because 27 does divide by 3. So I can put it back under one radical. And 27 divided by 3 would be equal to 9. And I can take the square root of 9, which is 3. If I have the square root of negative 125 over the square root of negative 5, I need to pull out the I. Square root of 125 over I, square root of 5. The i's here will cancel out. And you're like, well, why can't I just divide by the negatives? Because you've got to make sure you account for all of those negative signs. So you do need to pull out the i's. Now, these are not perfect squares, but 125 does divide by 5. So I can put those together under the radical. And 125 divided by 5 would be 25, and the square root of 25 is 5. All right, let's look at number 4. We have y squared is equal to 169. Here we are solving using the square root property. So I'll take the square root of both sides, and I get y is equal to plus or minus that square root of 169. You need to remember that when you're dealing with introducing a radical, you have to use the plus or minus. That is a perfect square, so I get y is equal to plus or minus 13. All right, let's look at another one. If we have y squared is equal to 11, I'm going to do the same thing on this one. And so I have y is equal to plus or minus the square root of 11. And the square root of 11 won't reduce any further, so we are done with that one. That's all there is. All right, let's look at y minus 5 quantity squared is equal to 49. Well, on this one, because the whole thing is squared, I can take the square root of the whole thing. So I get y minus 5, because the square root will take care of the square, is equal to plus or minus that square root of 49. So y minus 5 is equal to plus or minus 7, because square root of 49 is 7. Now I'm going to add my 5 over to the other side to solve for my y. And I get y is equal to 5 plus or minus 7. Now this becomes my two answers. I have to finish this. I end up with 5 plus 7 and 5 minus 7. Well, 5 plus 7 is 12, and 5 minus 7 is negative 2. Those would be your two final answers. All right, our next one would be 3x minus 4 squared is equal to 64. So again, we can take the square root of both sides, and we end up with 3x minus 4 is equal to plus or minus that square root of 64. I think my pen is dying, so let's come back with the black pen. So we can end up with this part. Now the square root of 64 is going to get us 8. So 3x minus 4 is equal to plus or minus 8. And now we'll add our 4 over and get 3x is equal to 4 plus or minus 8. And then we'll divide by 3 to finish solving for our x. So we have 4 plus or minus 8 over 3. Make sure when you're solving that you are bringing that where you solve for x. A lot of students like to stop at this point. Don't do that. Actually show that. Now, we're still not done because we have our plus or minus. We have all numbers. This becomes 4 plus 8 over 3 and 4 minus 8 over 3. So 4 plus 8 would get us to 12. 12 divided by 3 would get us 4. 4 minus 8 would be negative 4 over 3. So these would be your two answers. All right, the next type of problem that we're looking at is solving with the quadratic formula. So this will be 5a. Remember that the quadratic formula is x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. Our first problem we're looking at with this is x squared plus 6x plus 13 equal to 0. Remember, it has to be set equal to 0 in order to use the quadratic formula. And I suggest that you write what the a, the b, and the c is, because otherwise students tend to forget signs or they grab the wrong number. Our a is going to be equal to 1, our b is 6, and our c is 13. You never pull the x's into that. You only use the coefficients. So the x would be equal to the negative or opposite of b, so negative 6 plus or minus 6 squared minus 4 times our a times our c all over 2 times our a. Now I always put parentheses around my b squared so I remember the whole thing is squared. This will always get you a positive number for this part. Even if it was a negative, it will become positive on this part. Just the squaring. All right, so now we have negative 6 plus or minus the square root of 36. Negative 4 times 1 times 13 will get us negative 52 all over 2. My other thing is make sure you're always keeping that all over. Don't shrink down that fraction sign. That's another problem that I see for students. Negative 6 plus or minus 36 minus 15 will get us negative 16 all over 2. Now we need to take out the I. So negative 6 plus or minus I, square root of 16, all over 2. Square root of 16 happens to be 4. So negative 6 plus or minus 4i all over 2. Now our 6, our 4, and our 2, or our negative 6, our 4, and our 2 are all even numbers, so I can factor out a 2. So if I factor out a 2, negative 6 divided by 2 would leave us with negative 3. 4 divided by 2 would be 2. All over 2. The 2's will then cancel, and you end up with negative 3 plus or minus 2i, and that would be your final answer. All right, our next example is negative 6 equal to negative 4x squared plus 3x. Now, it all has to be on one side. It has to be set equal to 0. I'm going to move these two values over to this side. So I'm going to add the 4x squared and subtract the 3x. So we have 4x squared minus 3x minus 6 equal to 0. And again, we are using our quadratic formula. So we're still using the same formula. So again, I'm going to write what my A is, what my B is, and what my C is. So my A is 4, my B is negative 3, and my C is negative 6. So x would be equal to the negative of negative 3, because it's negative b, plus or minus the square root of negative 3 squared minus 4 a times c, all over 2 times our a. So that double negative will become a positive 3. Negative 3 squared, that will become a positive 9. That's what I was talking about. Whenever you square this, it's always going to be a positive value. I have a negative times a negative, so I know this will be a positive. 4 times 4 is 16, times 6 is going to get us 96. All over 2 times 4 is 8. So 3 plus or minus the square root, 9 plus 96 will get us 105 divided by 8. Now we need to look and see if 105 will reduce down. So 105, I know it's going to divide by 5, and then it will be, so that'll leave us with 21. And then 21 is 3 times 7. Oops. 3 times 5 times 7. None of those will get us a pair because there's just 3 individual numbers. So that will not reduce any further, and so this would be our final answer. All right, let's do one more quadratic formula. So this will be our C. So we have x squared plus 4x minus 5 is equal to 0. So my A is equal to 1, my B is equal to 4, and my C is equal to negative 5. Now I will point out, if you had moved the 6 over instead, you still would get the same answer. If you had decided to move the 6 over, you just would have had different signs on your numbers, but you still would have gotten to the same answer. So it works out either way you go to which side. I just like having my x squared with a positive coefficient. All right, so we're going to have x is equal to the opposite of b, plus or minus, or the negative of b, the square root of b squared minus 4 times a times c, all over 2 times a. So negative 4 plus or minus the square root of 16. Negative times a negative will make this positive. 4 times 1 times 5 will be 20, all over 2. Negative 4 plus or minus the square root of 16 plus 20 would get us 36, all over 2. The square root of 36 is 6, so negative 4 plus or minus 6 all over 2. This will get us 2 answers, the negative 4 plus 6 over 2 and the negative 4 minus 6 all over 2. Negative 4 plus 6 will get us 2 over 2, which is equal to 1. Negative 4 minus 6 will get us negative 10 over 2, which will be equal to negative 5. So these will be our 2 answers. So take note that on your quadratic formula, you can end up with something with an I. You can end up where you still have a radical. And you can end up with 2 numbers. And they can be fractions at this point, but 2 numbers. So there's 3 different ways you can get an answer on a quadratic formula. All right, our next problem, we have f of x is equal to 5x minus 7 over 4. Here we are looking to find the domain. What is the domain of our fraction? So because we don't have a variable down here, because there's 2 things you look for in the domain of a function that has a rational function with a fraction. You can't take the square root of a negative, and you can't have a 0 in the denominator. But because it's just a 4 on the bottom, it can never become anything else. It's just a 4. So because of that, our domain will be negative infinity to infinity. If we look at g of x is equal to x squared plus 1 over x minus 2. We don't have a square root in here, so we don't have to worry about that, but we do have a denominator. So we have to take our x minus 2 equal to 0, add the 2, and we get x equal to 2. If you look at this, 2 minus 2, oh, that would get us 0. That means x can't actually be a 2. Sometimes this is easiest if you draw a number line. We'll put the 2 there, the infinities. It can be everything but that 2. So it'll be from negative infinity to 2, union with 2 to infinity. Everything but 2 will work, but 2 will make us divide by 0. So that's where we have the issue. On our next one, we have h of x is equal to negative 2 over 2x plus 5. Again, we have a variable in the denominator, so we're going to set it equal to 0. Subtract the 5 over. We get 2x is equal to negative 5. Divide by 2, and x equals negative 5 halves. Again, if I draw it on a number line, and you don't have to, but sometimes it's easier to see. And notice I only put the number I get. I don't put any other numbers because they're not necessary. Otherwise, you've got to try and figure out where does this land on my number line. It doesn't matter where 0 is at. We only care about this number because it can be everything but that number. So negative infinity to negative 5 halves, union with negative 5 halves to infinity. So these right here, this is the answer you're looking for. You would need to show all of your steps. And on the first one, of course, it's going to be that. And this, again, is our domain. Okay? All right. The next one we are looking at, f of x is equal to x squared minus 5x plus 4. And for part A, we need to find f at 3. So we are plugging in 3. So 3 squared minus 5 times 3 plus 4. You're just plugging in the 3 into the equation. 3 squared would be 9. Negative 5 times 3 would be negative 15 plus 4. And when we add that together, we get negative 2. All right, part B, we are looking at f at negative 4. So negative 4, we're going back up to our original function, squared minus 5 times negative 4 plus 4. Well, negative 4 squared, again, because the whole thing is being squared, we're getting a positive 16. Negative 5 times negative 4 would be positive 20 plus 4. And as we add this together, we get 40. So all you're doing here is you are evaluating. You're finding, you are finding your value of your function at the values that are given to you. So you have a function, you're told to find this, and that's all you have to do on that. All right, the next thing we're going to look at is writing with positive exponents. So for number 8, we have 7x to the 5th, y cubed, z to the 4th, times 4x cubed, y to the 6th, z to the 9th. So here, we're writing with positive exponents. So far, we have positive ones, so we're just simplifying this. So this will get us 28, because 7 times 4 is 28, x to the 5 plus 3, because 5 plus 3 on the x, y to the 3 plus 6, and then z to the 4 plus 9. Because they're on the same level, all we do is add the exponents. All right, so this will get us 28. X to the 5 plus 3 would get us 8. Y to the 3 plus 9 will get us y to the 9. And z to the 4 plus 9 would get us 13. And that would be your final answer. All right, part B. We have 32 x to the third, y to the 8, z to the second, over 8 x to the 7, y to the third, z to the ninth. So for our number, 32 does divide by 8, so that'll get us a 4. My x's, my y's, and my z's, I need to figure out where they're going to land. I try to not just move everything to the top and then figure it out. You can if you want. You can move everybody up. Remember, when they cross over that line, they'll change their sign. So I'm looking at the x's have more positive ones in the denominator. So I'm going to move those all down. So I'll have 7 minus 3. Because it's division, we end up subtracting the exponents. So 7 minus 3. There's more y's on the top. So y to the 8 minus 3. There's more positive ones. And the z's, there's more positive ones down in the denominator. So z to the 9 minus 2. So that will get me 4. Y, 8 minus 3 will get me 5. X is 7 minus 3 is 4, so x to the 4th. And z, 9 minus 2, would get me z to the 7th. And that would be your final answer for that one. All right, our next problem, we are looking at 7x to the 6th, y to the 9th, over z to the 8, all raised to the negative 2. So you have to apply that negative 2 to all of your values. So 7 to the negative 2. Now here, because it's being raised to a power, we will multiply our exponents. So x to the 6 times negative 2, y to the 9 times negative 2, all over z to the 8 times negative 2. All right, I know that 7 to the negative 2 is going to have to move to my denominator. So 7 squared, because when it crosses that line, it'll change the sign. And then I have x to the negative 12, y to the negative 18, and z to the negative 16 when I multiply them. All right, that tells me that 7 squared, that'll end up being 49 in the denominator. My x's will have to go down because they can't be negative, they've got to be positive. So x to the positive 12 in the denominator, y to the positive 18, and the z's will have to go up. And that will get me z to the positive 16. So you can then move them to where we have all positive exponents. All right, the next thing we're looking at for number 9 is scientific notation. All right, so for part A, we have 8, 7, 6, 5, 4, 3, 0. That's our number. And we want to write this with scientific notation. So understand that with scientific notation, we want that decimal behind the very first number. So right now the decimal is back there, and I've got to move it to that point. So I'm going to move 1, 2, 3, 4, 5, 6 numbers. So this will end up being 8.76543, don't write the 0 if it's at the end, times 10, and it will be to the positive 6 because it was a large number. So that will tell me it's going to get back to a large number if I want to change it back. Our other number is 0.0002176. And again, I need to get my decimal place right there, and it's starting from there. So I know that the first part will be 2.176 times 10, and I've got to figure out how many places. I'm moving 1, 2, 3, 4 places, But because this was a really small number, I put a negative there so that it's understood that this was a small number. This tells me it goes to a big number because I can move that decimal back over and get back to the original number. So that exponent is important to know which one is positive and negative. Now to move it back, what we call that is standard notation. So let's look at this example. So the first one we have is 3.5678 times 10 to the 8. This tells me, because it's a positive, this is going to be a big number. So 3.5678, I have to move that decimal place over 8 places. 1, 2, 3, 4, 5, 6, 7, 8 places, which tells me I'm going to zero fill all of those. So those are a bunch of zeros there. So my answer will be 3, 5, 6, 7, 8, and 4 zeros at the end. So you don't have to do the scallops like I do, but I find it easy to follow where it's going. But you do, at the end, need to write it where it's clear to me that you understand the decimal place is not longer there. If you don't rewrite it, I will take off a point for that because it's not clear to me what you've got going on. All right. 6.9543 times 10 to the negative 5. That tells me that it's going to become a smaller number, and I'm going to move that decimal to the left side. So 6.9543, I have to move it 5 decimal places to the left. So 1, 2, 3, 4, 5. So that's where the decimal will be, and I'll have 4 decimal places in front of it. 0.000695543. And again, you have to be clear of where the decimal is. So you need to rewrite it without the scallops. So hopefully this will help you be successful on Major Quiz 2.